looked at that table, that registration table. It includes some information about what we do. So currently we work with Illinois EPA for this energy code training program and also wastewater treatment program. So if you know of any wastewater treatment plant that needs some help, we go there and then we do audit and provide some recommendations on what kind of improvement they could make and how much of energy and money they could save. And we also work with utility companies like Ameren and ComEd and help clients to get some incentives through the utility incentive program. And also we work with other state agencies for energy efficiency related work. So currently, Illinois State Energy Office is in Illinois EPA. I don't know if you guys are aware of it, but before it was under DCEO, the Department of Commerce, but now it's under Illinois EPA. So we SEDAC is an energy code training provider on behalf of the Illinois State Office, State Energy Office in Illinois. So our program is not only just this in-person workshop, we also have our energy code website, so it's easy for you to navigate through all the information related to Illinois Energy Code. And we do have a technical support line. We have 1-800 number, and we also have the email address, which is energycode@sedac.org. That's the best way to get a hold of us if you have any energy code related question. You can always send us an email like, hey, I ran into this problem and not sure, what would be the good way to interpret it or something like that. So email us if you have any comment or questions. And also we do have, we are hosting webinars too, and actually this Wednesday, we're going to have an hour-long webinar at noon. We are going to talk about commercial lighting. So if you are interested in knowing more about commercial lighting energy code, feel free to register and also, let your colleagues and coworkers know if they're interested in energy code and especially lighting, sign up for our webinar. And also we have like online on-demand modules. So this is like a design to finish an hour or hour and a half for each module. So we have 4 modules developed. One residential, and then commercial envelope, commercial lighting, commercial HVAC. So this is designed for people who don't necessarily have time to come to in-person workshop or cannot schedule the webinar in time. They can kind of sign up and go through and, they can just self-guide through the energy code information. And each module has a quiz at the end. So, if you pass more than 70%, you get a certificate. But you can retake as many you want. And if you flip over that slide, the screenshot is the look of our energy code training website. So as you can see on the left, there are many like webinar, FAQs, contact us, the general information about energy code, Illinois Energy Code. And then Energy Code 101, because today our title for this training is Energy Code Basics and 2018 IECC Update. So we're going to spend some time to talk about Energy Code Basics because each, requirements are important, but also I think it's important to know the little bit of background information of Energy Code. So Energy Code 101, we said building codes are state law, so period. If anybody is violating the building codes, actually they are violating the law of the Illinois state. I will just say that much, but what if somebody is violating? Yes, there's a lack of mechanism to actually kind of hold somebody accountable, I guess, but it is the law and everybody needs to follow the building codes. And energy code is a part of building codes, right? And sometimes energy code is not treated as a top priority out of the building code family, like a fire or structure, plumbing, but energy code is also a very important part of building code. So to talk about a little bit of the general things about energy code, we had some slides explaining about how energy code is developed and how it's complied and how it's enforced. And first, the development. Energy code, probably as you know, is basically like there's a national model code that is developed by two major associations, one ICC, the other one ASHRAE. And then if you look at that colorful graph, that shows the history of model code's improvement, meaning the red bars on top, that's for the residential energy code, and bottom blue bars, that's commercial. And x-axis, horizontal, that's the time. It starts from 1975 to 2018. And then y-axis, vertical, it's a 0 to 100, 0 to 100. What it shows is that if we say the building that is built to 1975 model energy code, let's say the energy consumption of the building is 100, what about the next version of the code? What about the next version of the code? So it shows, it starts with 100 and then 80, 70, 90, and then right now 2018 it's like a 58. I cannot even see this, but it's hard to see. It's like a half. Almost half of the energy consumption, meaning that energy code has evolved to save energy. So any buildings that comply with the current energy code, that is actually saving half of the energy that compared to the building that was built based on 1975. Yay, it's on! So you can look at this. So, but if you remember the AIA, they have a goal of 2030, meaning by 2030, they're hoping to have net zero, achieve the net zero, meaning all the buildings or all the new buildings will be zero here. So we have actually long way to go. It's good that we are not increasing, but it's kind of getting tighter and tighter, as you can see, because the technology, has evolved. Like lighting, now we have LED. I'm not sure what else could add to save more lighting energy. Maybe some more controls. And then HVAC equipment. There are lots of good equipment now to save more HVAC, side of energy. Yes, efficient equipment, but maybe there gotta be some more creative ways. So it's getting tighter and tighter. There are no more low-hanging fruit.
And you had talked about, for 2012 was kind of the last time you had seen training. You could see there was a big jump from 6 to 9 to 12. We're now getting into, the code is transitioning more rather than these major steps in more as far as usability. And how do we give, flexibility so that way people can build better buildings given their circumstances and what is more locally available, rather than just say, this is the one way you have to do it. Well, that doesn't fit for everyone.
So that's how the model code is developed, and then adoption. Actually, Illinois is one of the few states who adopt the most recent model energy code. So as you can see, more green is toward more like a recent energy code. So somehow Illinois is painted with green because we have our amendment. So in terms of DOE's perspective, we are not quite at that model energy code, 2015 or 18, because we have some Illinois amendment that weakens the energy efficiency of the model code a little bit. But in general, Illinois is one of the few states who is leading the energy code in terms of if you look at the nationwide. And then, so adoption process. I think probably you guys are very interested in when the new code will be effective. So until the day before yesterday, until like a Friday, we've been saying that, or Thursday, we've been saying it'll be March 1st because that's what we heard from CDB. And CDB just told us that they couldn't put that energy code agenda on the JCAR meeting on February agenda, so it got pushed. So it will not be March. It will be maybe April if they put that agenda on the JCARs on March meeting. So if you see others and hey, SEDAC told us that it'll be March 1st, and tell them that news, it's updated news, it's not March 1st, it's April 1st, maybe. The earliest could be maybe. So CDB is in charge of, reviewing and adopting, and then, now it's a JCAR, that's what I mean, they just need to rubber stamp, but it takes some time. So maybe April 1st is a new date that you need to remember. So typically it's a permit application date. Any project that apply permit on or after the new effective date should follow the new energy code. So Illinois Energy Code, it explains what it is, and all the buildings in Illinois should follow. But one thing that I point out, if you are ever involved in state-funded building, before state buildings should follow ASHRAE 90.1 because that's what is written in Illinois administrative rule. But that will change for this new upcoming new cycle, so maybe April 1st, that state-funded building also could do IECC, meaning now they have option. Before they didn't have option. They need to follow ASHRAE, not IECC. Now they have an option to follow IECC and ASHRAE. That is the biggest change. So compliance. So we look at the study that is done by MIA, and they have Illinois Enforcement Survey on the existing commercial buildings. So they surveyed like 69 code officials in Illinois to find out what's the status of the energy code compliance in Illinois. And then they asked many questions, and one of the questions that they asked to the code officials is, what is the biggest issue in enforcing the energy code? And 72% of code officials said, oh, that's because of lack of understanding from builders and designers. So there are other things, lack of clarity from state and jurisdiction, lack of code officials or inspectors and others. But because we asked code officials, they blame the architects and engineers. But I'm sure if we ask architects and engineers, they will say something a little bit different. But so to comply, the compliance done by architects or contractors who are actually designing buildings. So importance of compliance is, we cannot overemphasize. So
does this fit with what you guys are seeing in your applications, or where you run into problems? Is it just there's a lack of understanding, or is it, hey, there's some technical reason that's causing an issue, or what is it that you're finding the challenges in the field?
Most of them don't even know.
Lack of okay.
See, that goes to the 75%.
Call it what you want.
Well, and maybe that's part of it is, do they even realize that the state has an energy code at all?
Well, they realize.
Oh, okay. So they Okay.
Okay. All right. So I want to actually point this out. So we're here today, and it is a small crowd, and we kind of knew from the get-go it's gonna be a tough sell. And we also provide a workshop in Chicago area and Chicago suburb, and we have like over 100 people. And still, I get requests from people in Chicago area and Chicago suburb. Hey, we want you to come here. We have 200 people, 100 people. Can you come here to talk about it? And even they say, oh, we'll pay you. So, but the reason why we said, No, but we will come and monster the reason why we're here, even though there are kind of better opportunities that we want to talk to people who had hard time to have energy code training before and who never had energy code training, or things. The energy code is kind of like the bottom of the priority list. That's why we're here. So we are so glad that you guys are here, and I hope you could spread the word and then support the energy code. Yes.
Now, residentially, how do I put this? They basically need to find a way to make the appraisers where they can appraise it with the conditions of this.
Right.
Needs a new energy code or something like that.
Right.
Right now, they can't throw anything like that in there on the appraisal.
Right.
So that stops people from wanting to do
But
it.
is there a thing that stops them? Could it be an option? Somebody opposed
I
to
don't
that?
think they have anything a basis for determinations at this time.
I see.
That would be an interesting question as far as what is, and this
The value
would be,
of it.
well,
Right.
what
That's
is,
basically what
what
you're
is-
to look at.
They want to spend $2,000 on their kitchen cabinets,
Yeah.
not upgrading.
yeah, well, I'm looking at from the reverse. What is is there an appraisal impact of this home does not meet code, period? This is not a state. That's what, almost from the other side saying, if you don't even meet the state law,
Right.
Well, I understand
But-
what you're saying.
but
You
yeah.
have to go with you'll probably end up with a lot of balking with that.
yeah. And I can appreciate I want things that look pretty, not necessarily what is going to make my home more comfortable, what's going to make it have a lower cost going forward.
But I
You
think
find that more to homeowner when they're getting involved in it. You probably see that too, versus a contractor, you're doing a spec home or something like that. If you follow my train of thought, the homeowner's going, well, I want to see what it's going to cost me later on. They're more interested in what their return is.
So I think the education to homeowners or realtors should be also the emphasis for the energy code training.
Yeah.
I think if we explain in the
Assessors.
long term, that
Okay.
is
That's a good target audience there.
yeah.
I think that's a good point, because this was back when the discussion back in, I think, like I said, it was adopted 2012, maybe it was adopted in 2013 in Illinois, and there was this huge, from builders, so it's costing much more to build these homes and more input into the homes, and they're not appraising out any different.
Yeah.
So there's lack of knowledge from the appraisers, who's selling them, so the homeowners were not seeing a difference mathematically in my mind.
Right,
Yeah.
let's put the
Yeah.
uneducated one, because when you get some of them that are doing their own, they become pretty educated on the stuff. We've
Yeah.
had a few passive houses built, things such as that.
I'm a huge fan of that.
Okay, owners have done them themselves, and they went to great lengths to find everything. Now, there was some stuff sometimes with putting the foam underneath the footing, because we run into the footing doesn't have the compressive strength for it, so they had to get special foam for that. When the passive design place was selling, it didn't meet it. Yeah, they didn't like it.
Interesting.
Yeah, that was a 2-month deal.
Yeah, and some of this, as technology proceeds, and I can see where you would have a lot more pushback with the 2012, because that was a major step.
Yeah.
Now, I get the question that comes to mind on me when you get into the commercial, and he probably knows something about this too. You're required, as the energy code has progressed, they decrease the amount of fresh air. Have they done anything with air quality inside the building to see if that's been affected?
Yeah. Well, that's where the
EPA.
well, the energy code, it isn't that it's been restricting the fresh air intake as much as it is where it's triggering. You must do energy recovery for that fresh air. that threshold has been working its way down. Now in the 18, there was a little bit of a change to, because in the 15 code, if you have continuous or near continuous ventilation, beginning with CFM 1, you had to do energy recovery on it. They've now loosened that just a little bit. I mean, and it varies. It's still pretty minimal, but it's no longer starting at the first CFM. You now have some allowance for it before you have to do energy recovery, which, or again, anytime you're ventilating and putting air outside, it's wise to get that energy back out of that air rather than just chucking it outside and being like, well, I'll just bring in some new stuff and condition it all the way from outdoor conditions. But Sumi mentioned our modules, and they are open to anyone, and they are targeting sort of a beginner audience. So if you run into homeowners, they're welcome to come in just the residential module, where it's like in 1 hour you can pick up a lot of information where it's like, oh, I hadn't even thought about that. Anytime I do talk to people about passive house, where you can build a home with basically almost no heating or air conditioning equipment. You do have to have ventilation equipment, and they're like, well, why doesn't everyone build that way? I'm like, because no one knows to ask for it.
There's also the issue with you get into some of the passive homes now, because they were having trouble with the moisture in them. Mm-hmm. So they draw the return air out of the bathrooms and the kitchen areas and filter everything.
Yeah, that's we're starting to learn a lot more, and I've seen a lot more about building science and trying to say, as we build better building, as we try to build better buildings, what is the science that we don't cause another problem? Because if
they were
you get them so tight, if you forget about moisture, that's going to cause you a real nightmare.
All right. Next slide. So code development is done in the nation, national level, and then code adoption is done in the, like a state or local level. And then enforcement is definitely done in the local level. The code enforcement is the local, code official's duty. So what are the issues in the enforcement? And these are the comments from, code officials, throughout Illinois. And they say, oh, lack of knowledge for code officials. Energy code is very confusing and hard to understand, so we don't know. That's why it's hard for us to enforce. And then contractors resist. They say it's gonna cost double of whatever it is. And then I have so many other things. I have fire code, I have accessibility code, electrical code, and those things to inspect. And energy code is always at the bottom of my list. And then they say also, my town enforced this, but then next town across the street enforced something else. So it's really hard to even talk about energy code to the builders or other people. So those are all the challenges that we hope we could help to improve or make it better. But that's the reality. So, and also when we say energy code, people think automatically it's for the new building, but actually the matter is most buildings that are built or the building projects are existing buildings, either renovation or addition. So there's a separate chapter in the energy code, like chapter 5, for both residential and commercial. So it's not like it's mainly for the new building. And reality is that when we ask the code official what percentage of your permit is for the existing building, and there are many people saying over 70%, right? So actually the existing building, renovation or addition, those are important things in the energy codes if we're talking about the impact. yes, of course, there's new buildings, but in terms of building stock, number of project, definitely existing buildings. So residential energy code, like to easily understand in terms of components, ventilation, water heating, insulation. So like something like 8 building components that energy code is dealing with. And those 8 components under residential code, it's like for section 4.2 of the residential code in the IECC, thermal envelope. Actually, this is talking about this same color: fenestration, air sealing, insulation. Those are, we're talking about it under R4.2 in the residential system. HVAC system, water heating, it's under R4.3, and then electrical power and lighting is R4.4. The commercial code, the same 8 elements. One thing different is in the commercial code, 4.4, the surface water heating has a separate section from the mechanical system. So in terms of building components, I think it's just easy to understand. These are the main components, and those are the sections that talk about those components. So 2018 ICC, so there's a physical book, but also you could go online, you could come to our website, then there's a link, or you could follow this link on the slide, and we will post this PDF to our website, so later on if you need to print more or need to refer back, you can find it on our website. And if you follow this link, then actually there's a whole web version, free web version of the code. So you can search through and then try to find the exact code language. So this is only the IECC. So Illinois amendment, you need to look at it from the separate source. And that'll be under CDB, or you could come to our website and we will have a link. This is Illinois amendment, and this is a link to the 2018 ICC. For you to understand the whole Illinois Energy Code, you basically need to have 2018 ICC book or this web version, and then Illinois amendment. Don't forget about the Illinois amendment. It's like a 15-page amendment, but it struck out some languages from the ICC and added or deleted and changed some numbers. So those two. Not only this, you need the Illinois amendment. Yes.
Most of the language go into the administrative one, chapter 1.
Not necessarily. There are some languages.
I know it has one about the 4 foot below grade.
Yeah.
Basement or crawl space insulation.
Right.
Yeah.
And there's an air change rate difference too. ICC says 3, and then Illinois used to say 5, and now we're moving down to 4 for the residential.
Yeah, a lot of the changes is administrative. One of the bigger ones is the definition of a residential building is slightly different between the ICC and so there's an Illinois amendment on that. Again, this it's not a very thick packet of amendments, and a lot of it is we've struck stuff, and so they have to show all the struck stuff and here's what I'm adding. So
I think one question came to our tech support center last week. It's about the residential renovation project. The question was that, we have this a main house, and we are building this addition. The main house used to have 2 furnaces, and then now I want to have just not a new furnace, but just extend the ductwork from the main house to heat this new addition. Do I need to have a duct testing? Because according to IECC, yes, you do. But Illinois amended out, saying that the IECC says it needs to be within some feet. If then you don't need to duct 40 feet. Then you don't need to do duct testing. But if it's more than 40 feet, then you need to do the duct testing. That was the IECC language. But Illinois amended out, saying that delete that distance. So if it's just taking out from the existing ductwork to condition the addition, you don't need to do duct testing. But you need to seal the duct per code, but no testing needed. So something like this, the Illinois amendment has some special like a exemption, not necessarily more stringent. Mostly it's less stringent.
Trying to make it more palatable.
Yeah, well, and trying to say what is reasonable and how are you going to do that? Because, like in that case, when you say, okay, I have to do duct testing, which it's a little strange in the book, you have to do duct testing, I believe, on almost all systems. But if everything is inside the thermal, you may be required to do the testing, but you don't necessarily have to meet any particular threshold. So there's some weird things where you look at it and it's like, well, if I don't have to meet a threshold, is there a reason why I'm testing it?
Well,
other than just to say, is it really leaky that I forgot to seal something?
The prescriptive test, there's a standard for testing, but if you do performance, you need to do testing, but there's no number that you need to. So
there's some weird stuff in there, but yeah, they have tried to make it a little more usable as far as how do we be reasonable, particularly, again, most of this is existing construction. Trying to test ducts that are 60, 70 years old. Yeah.
So this is a good resource for you to go through, especially if you have something that you want to find out. You can type in keyword, the search function, and it will highlight. You cannot copy or paste, you cannot print, but you can just look on the web.
Yeah, you can do a search a lot easier than trying to find the word in here.
Flip through the book. So before we go further. So always the energy code is two parts, like one half residential or a little bit less than half residential provisions, and the other is a commercial provision. And you'll be amazed that sometimes that is a kind of hard question to answer. So residential building per energy code definition is
per Illinois amendments.
Yeah. A detached one family or two family dwelling, or any building 3 stories or less that contains multiple dwelling units. And then Chicago is an exception. It's a 4 or less. So examples of residential buildings are these, like a townhouse, dormitory, monastery. Those are residential buildings. What about commercial building? What's the definition of commercial building per energy code? Anything but residential building. That's literally what it says in the definition. Because it's hard to define all little things. If it's residential. If not, it's a commercial. So, but there's a mixed building, that has both residential component and the commercial retail component. What about those? So this is just a quick quiz for us to just remind that what the definition of residential buildings versus commercial building. So 5-story mixed-use building with 2 stories of retail and 3 stories apartment in Chicago. Is this a residential building or commercial building? It has residential occupancy and commercial occupancy, but in terms of building, commercial building. Yeah, because it's 5 or more. In Chicago, it should be 4 or more, right? 4 or less is residential. So other than that, it's commercial. So 3-story mixed use, 1-story retail, and 2-story apartment in Bloomington. Is it a residential building or a commercial building? Residential building because it's 3 or less. And then how about this? 5-story single-family home. Residential building, commercial building. Emphasis on single family, not story.
Correct. Yeah,
Yeah.
It's a residential. Yeah, it's a little weird to see a 5-story single family home,
But if there is, It is a
bit
residential
theoretical.
building
Yeah.
because no matter what story, it's a single family home. Three-story hotel.
Commercial.
Commercial because it's not a permanent dwelling unit. It's even though it's a 1-story or 2-story, it's a commercial
Temporary
building.
occupants.
So now we're going to talk about the actual changes on this new model code 2018 IECC commercial side. So compared to 2015 IECC, actually in terms of energy efficiency, not that much. Just like the initial estimate done by DOE is maybe 2 to 5% improvement. And then mechanical section is the one that has changed a lot, not because there are lots of requirements changed, but they just reorganized it. So if you are accustomed to look at all the section numbers in 2015, now it's kind of all just organized. Or, to make it a little easier to navigate. That was the intention behind it. And then there's additional efficiency package option in commercial 2018 IECC. So, to comply with energy code, you have some options. You could do prescriptive pass, and in general, you could say prescriptive pass or performance pass. If you are doing prescriptive pass, then not only you need to meet all the mandatory plus prescriptive requirements, plus you need to pick one of the additional efficiency packages. That include more stringent LPG or renewable site or better HVAC equipment, things like that. But 2018, they added 2 new additional efficiency package, which is 1, enhance envelope performance or reduce air infiltration. So if you are complying with energy code, Illinois Energy Code with prescriptive path, then you need to pick one of the additional efficiency package on top of mandatory and prescriptive, and now you have 2 more options. Any questions?
So it's things like better lighting, better HVAC. These 2 is like additional insulation or a more tight envelope than the minimum. And so, again, earlier I mentioned about the code trying to be a little more usable and provide a little better flexibility to say, how can you achieve a better building? Here's a list of 8 different options for you, and you can choose the one that fits your application best. You may already have great lighting, and so you say, okay, I'll do lighting, or it may be through, I can get a better efficiency, air conditioner and heating system for not much more money. I'll take that one. So it's providing a little bit more flexibility for the building the building purchaser, for lack of a better term. Something that I don't think we cover in this, I think we'll probably link to on our website, is as far as trying to figure out how are people meeting the energy code. The city of Chicago has actually provided a very nice template as far as here's a checkbox for as they go through, and that they can then turn around to you as the code officials and say, here's how I'm planning on meeting the energy code. I'm following a prescriptive path, and I'm choosing, this added efficiency option. And so that way, when you go to do a review of the prints, you know where you're looking, rather than say, okay, you have 8 options, you figure out which one I picked. And providing a little better clarity and guidance, which probably is going to be very helpful to you guys when anytime you're going through this.
And also for the designers to use it as a checklist. Oh, okay, that's right. I need to meet this mandatory requirement plus this and plus this additional. So it's like a 1-page document that any project that is applying for the permit in the city of Chicago, they need to fill out that. you can go and check it out, and actually you could use it for your own project or your own municipality. I think they wouldn't oppose to an idea of you copying and using it. And another changes in the Commercial Energy Code in 2018, IECC, is they have some language changes. And one thing that I want to mention is that for control, like a lighting control or HVAC control, before it was said, oh, this control should be capable of doing this. But now they thought, that could be a loophole. Some controls could be capable of something, but not doing it, right? Not programmed it correctly or not used it correctly. So now they changed the language to be configured, meaning it should be capable of doing that and should be programmed to do that kind of control. Then there's a new appendix in 2018 ICC. It's called CA, a Solar Ready Zone in commercial section. So residential section, this appendix was there in 2015, but it is new to commercial section in 2018. What it is it's not a mandatory or required section, but it is, appendix. It's a reference. So if this is for the future solar project, these days there are lots of projects that are thinking about solar, and maybe if not now, maybe later. So this is some kind of guidance, some guidances that you could look up to if you are thinking about solar project in the future for the project. So if you are in the municipality, you may be able to make this as a mandatory item, but it's not required per Illinois State Energy Code. And then ASHRAE 90.1. So today's workshop, we are mainly talking about ICC, but we are talking about ASHRAE 90.1 because ASHRAE 90.1 is a one compliance path that you could choose. That I told you that to comply with Energy Code, basically you either follow a prescriptive path or performance path. The commercial, actually, you kind of have a three option. You either go to prescriptive, performance, or you can close this book and open up the ASHRAE 90. Because ASHRAE 90.1 is one compliance path that IECC says it's okay. So in a way, you could comply with the IECC with using ASHRAE 90. A little confusing, but anyway. So I don't imagine that you guys do a lot of projects using ASHRAE 90.1. Have you ever done compliance, Energy Code compliance using 90.1? Nope.
Fairly uncommon.
But if you do, these are the things that we want you to make sure that you understand. So ASHRAE 90.1 2016, so that's the code. If you're following 18 ICC, 16 ASHRAE is the one. There are new climate zone map. For the thermal envelope, depending on climate zone, there's a different requirement of R value or U factor. So ASHRAE updated their climate zone. So if you have a project in that border area, those 6 counties change from 5A zone to 4A. So that kind of changes the requirement for the mainly envelope. But remember, this is only this only applies when you choose to comply with Energy Code using ASHRAE 90.1. If you use just ICC did not change the climate zone. So 2015 version, ASHRAE and ICC have the same climate zone. 2016 ASHRAE, 2018 ICC have a different climate zone. Because as you can imagine, the climate has changed. The ASHRAE kind of updated theirs, and then ICC said probably, maybe we'll do it later, but not now. And then there's Appendix G. It's called like a performance-based compliance path. And before, this was mainly used for the LEED project, for the above code energy efficiency program such as LEED. So it wasn't a compliance path. but now it is a compliance path. So if somebody's using, somebody has a LEED project, then they don't need to build two separate models for LEED and energy code compliance. Before they had to, but now this is also the compliance path. So Appendix G could be now used as a compliance path under performance path. Those are like a big changes in the commercial side. And the residential side, no significant energy efficiency change, virtually zero. And then there's a definition change approved. So before it was approved by the National Testing Organization and things like that. So there are some like a more stringent requirement saying what is approved. But now 2018 ICC, the definition of approved has changed to simply acceptable to code official. So if code official said it's acceptable, it is approved. So now as a code official, you have more authority and more responsibility. And so it doesn't require to go through any testing or anything. If you deem that this is acceptable, then it is approved per code. And then inspection, before it said accessible and exposed, now it says visible and able to access. So it's kind of same thing, but try to make it more easy to understand and clear. So 2000 ICC updates. I think from here we're going to talk about it the component by component requirement changes, and I think Brian is ready to take over.
We're trying to kill you in details here, realizing this is more beginning. This kind of gives you a layout as far as how the 2018 code is laid out. Sumi had mentioned earlier that several of the HVAC measures they've rearranged some of that, and I've found in using the code, it flows a lot better in the newer version versus the older one. Trying to look at just mechanical systems versus service water heating. In the residential, they kind of consolidated because there's almost nothing in service water heating for residential. So on the commercial side, something we talked about as far as why should someone comply with an energy code? Other than, yes, it's state law, but the energy code is really more about looking at building science and safety, because there's certain things, in like here, noting there's a change here as far as if you're doing a heated slab, they're now requiring a minimum of R5 insulation under the entire slab. What is it that we're trying to provide there? Is that thermal break between the slab and the ground. You think about your cup of coffee in a styrofoam cup. Well, what's the R value of that cup? 1, 2, almost nothing. And so, but that that protects your hand against a 180 degree cup of coffee. When the insulation, while important, we really want to make sure that thermal break. And here in this depiction, they also talk about making sure there's a separation between the slab and your drywall. These are good details, and some of this, I think, is what you're finding in the Keys for Success books. And noting here, why do I need to make sure that I separate the drywall from that slab? Well, that slab is likely to conduct moisture, and I don't want to put paper up against the moisture source and end up with mold. So that's where the energy code is really trying to come into play and saying, as we try to build better buildings, how do we try to prevent mistakes that are going to cause us real harm later? This is another one as far as in the IECC, they call out combustion appliances and building sealed combustion rooms, basically, for appliances that are using outdoor air. Because kind of from a, again, that building science perspective, that room, if you're pulling outside air in for combustion, well, that room is likely to be kind of outdoor conditions. So saying, okay, we want to thermally isolate outdoor conditions from indoor conditions. Now, the code makes it real easy that, well, if you use sealed combustion appliances, well, now you've provided that isolation through that. Illinois has removed this section for both the 2015 and the 2018 versions. Removing that purely because they look at it and say, well, it costs more to build the building right like that. That's true, but again, the code gives you an option as far as here's a way to get away from having to build that room. Now, VFDs, these are getting more and more common, less and less expensive. So they continue to expand because they are getting less expensive. The code is finding they're more and more cost effective to put in more and more places. This used to be upwards of 5 and 7.5 horsepower where it required a VFD. Now it's starting with 2 horse. So once you're above that 1.5 horsepower, now you have to start putting in VFDs. And I think a lot of what we've been encountering, people are doing this, and not so much from the energy perspective, but just from a reducing surge on my buildings and saying, well, rather than putting a starter in, I'll just throw the VFD in. It's about the same cost, and we'll move on. Turn down for HVAC. This is HVAC, oversizing that, as you guys know, that is really problematic from a performance perspective. If you oversize it, and with the system, when you're getting down here into this orange triangle, you don't really need the heating or the cooling, but with variable air systems, as you run down, you get to a point where you say, well, I can't turn down anymore, so now I don't really need heating or cooling. I'm paying to move the air, I'm paying to overcool the air, and then paying again to reheat it back up so I don't overcool my space. And so now I've paid 3 times to not really do anything. The code is reducing or enhancing how far these systems now have to turn down from about 3 to 1 to 5 to 1 turn down. Now that can be real problematic if you oversize your HVAC, which I'm still trying to I've yet to been able to get a good explanation as far as why should reheat in a good design system that we are varying the air system, why should I ever actually need the reheat? Because that to me is just, I'm covering a bad design. Just from my perspective of, if I don't need heating or cooling, turn off the air, because I probably don't have anyone in the room. And some of this is looking at saying, well, do you tie it to occupancy sensors so that if there's no one in the room, don't heat or cool it, unless it really needs it. Right? Adding automatic control for heating and air units for hotels and motels of 50 guest rooms or more, or over 50 guest rooms for hotels and motels. So this is one way to do it. I don't know, have any of you stayed in a place that have these yet? I've seen them in a couple of places, but so it could either be a key card slot at the door where, as you come in, you put your key card there, where you also then don't have to worry about, wait, did I leave it on the dresser? Where did I leave? It's right there by the door for you. It could either be done through that, hotel management system, and occupancy sensors. Actually just stayed at a place last week that had an occupancy sensor for the HVAC. Okay, that's interesting, effective. So again, trying to say, how do we get better when people aren't in the spaces. Vestibules, this was another thing. We've had a fair bit of discussion over the years as far as how do you best control vestibules. We've seen a couple of different operating parameters, one of which is, you kind of overheat, or you kind of overheat that space in the winter, so that way when the door comes open, it doesn't, get that blast of cold air coming through, and trying to provide that buffer. So we've seen that methodology. The code finally has given direction on this. Vestibules, kind of designing them to be tempered spaces. It's trying to create a buffer between the inside and outside, and so just using them as a tempered space. So here noting maximum set point of 60 degrees. Now they even go a step further and say, beyond just that set point, having a disable, where the heating will only come on if the outside temperature falls below 45. So they've gone one step even beyond just set the thermostat to 60 degrees. And similarly with cooling, again, we're just trying to temper these spaces. There is, did come across one recently, there is some allowances, and I will note this number in the corner here is the actual section. So if you come across something you're like, oh, that would be good, what's the actual, all the text that goes along with it. And so vestibules is one area that we've gotten a question or two about as far as, okay, what are alternative compliances from a vestibule? One of which was a gym that they're like, this is in a warehouse. The man door is right next to the roll-up door that we keep open basically all summer long and fall and spring, and we only close it during the winter because there's no air conditioning in that building. And saying adding a vestibule is not an ideal situation. So for them, after doing some discussion, they came back and determined that an air curtain was good for their application because of the infrequent use they needed. Luminaire lighting level controls, this is something where rather than necessarily having centralized lighting control systems for larger buildings, each fixture has its own control. So typically they'll have their own occupancy sensor, their own photocell for daylight harvesting controls. And in order to qualify for this, they have to have wireless reprogrammability. Because with these, you can also typically tie them to switches, or you can group them together. And so if you have open plan offices or things like that, where you may reconfigure the space, this might be a good feature or a good direction to have as far as saying, okay, today these 4 lights are part of someone's office. Well, a couple of years from now, I may have shrunk the cubicles and now they're independent spaces from each other. And those 2 are now a hallway and these 2 are independent offices. So having that ability to change going forward. Occupancy sensors continue to advance and be found in more places. Starting with 2018, open offices have to have occupancy sensors now. And this is for open offices, I believe it's over 300 square foot, and each zone cannot be over, I want to say, 600 square feet per zone. So it can get a little hairy. So this is now where occupancy sensors are required. We've had classrooms and training rooms for a while, break rooms. As you go through this list, then you have this lovely catch-all, or this lovely, other duties as assigned, if you will. Other spaces less than 300 square feet. And so with this, there's not a whole lot of places around that don't require some kind of occupant sensing technology. Now, that is one difficulty that I do run into when trying to read some of the codes. Is the code will frequently talk about occupant sensing controls, which is not necessarily an occupancy sensor. It could also be a vacancy sensor. So the lighting controls people have kind of come up with these two terms: occupancy sensor and vacancy sensor. But the code lumps all of it under occupant sensing. Are you familiar with what the difference is between those two? Okay. An occupancy sensor will automatically turn the lights on when you walk into the room and automatically turn them off after you've gone. A vacancy sensor, you have to manually push a button or flip a switch to turn the lights on, and it will automatically turn them off after you've gone. So one is an automatic on and the other is a manual on. And both of them fall under the term in the code, vacant or occupant sensing control, because both of them do sense occupants. So it's a little bit tricky. About the few places that we've come across that don't require it are patient care areas where patient care is directly provided, stairwells, and some hallways. But most rooms now require it. Daylight responsive. This is one area I always like to call out the exception, because if you go through and use this exception, it makes your life a whole lot easier. And so it allows you to eliminate the requirement for daylight harvest or daylight responsive controls. So what it does is, if you reduce your total power density by 40% of the weighted area of the daylit zones. What does that mean? So for an office building, I'm at 0.79 watts per square foot. So if I have half of my square footage is in the daylit zone, if I take my total building power budget for lighting, and I can reduce it by 40% of 50%, which is 20%. So if I go from 0.79, if I'm under 0.63, I'm done with daylight harvesting controls. Don't need them. Which means I don't need to buy them, I don't need to install them, and I don't need to commission them. And I don't have them there to break. So frequently, as building code people, I think we naturally don't want to use exceptions. This is one I'm like, please use it, because it simplifies your life. And particularly, any reasons why they came up with this 40% number that you have to reduce your lighting power by 40%. Any suspicions as to why that might be? How much do you think daylight harvesting control saves? About 40%. So if you didn't put the watts in, you've already saved them. Exterior lighting controls, this has increased in stringency. Previously, you had to have either daylight shut off or a photocell, or time switch controls. With the 2018, you now have to have both. Now it could be in one control, or it could be two controls in series. So you could put a photocell with a timer and meet the requirements. And part of that Decorative lighting has to be turned off during non-business hours, and the code does give a couple of different ways as far as determining what is non-business hours. And there's a lighting setback for non-landscape lighting. So your parking lots and things like that requires 30% of the wattage to be reduced. So that could be I dim them, that could be I turn my far ones off, the ones further away from the building, I'm going to turn them off overnight. This is one area that I think might be beneficial to look at perhaps a possible zoning, or not necessarily a zoning issue, but looking at trying to do across the board standard rules and saying, okay, I'm going to take this guidance for new construction and make it part of policy, public policy. Because, again, looking at it saying, does it make sense to light everything up when no one's around? Also, this can be one challenge when you get into a new business moving in next to an old business. So the new business might have to have this turn off next to the old business that doesn't. So this is one where I could see it where you look at, might be a good potential for local language adoption and say, this just kind of makes sense. We're all going to jump in the pool together, not next year or not next week, but say within 5 years, making sure that we've got this. When calculating budgets, this was one big change. Now the NEC for track lighting, it says 75 watts per foot. Well, the energy codes have said 30 watts per foot, and now in the IECC, they're going down to 8 watts per linear foot of track. Any suspicions as to why that's going down to 8 watts? If you tried to put 30 watts of LED lighting on a track per foot, on every foot, that'd be one bright space. So they've looked at it and said, yeah, 8 seems to be a good, a reasonable number where you can get plenty of light and still be at 8 watts per linear foot without just going crazy on light. Which also helps when you're doing your budgets for places that do have flexible track lighting. Again, they're slowly coming down in lighting power. LEDs keep getting more efficient all the time. So offices, a little bit of a reduction, 4%, yay. Libraries is the big one. Dropping from almost 1.2 down to under 0.8. So over a third of reduction. Part of this is you think about what a library, what does a modern library look like as compared to an office space? A lot more computers, a lot less in the way of just stacks and stacks and rows and rows and rows of books. And so when you think about how much air conditioning load is that you're no longer having to budget for, because in some of your designs, if you're actually budgeting, as part of just your simple HVAC design and say, well, I know the lighting designer could give me 1.19 watts per square foot. Well, not sure what he's going to come up with, but I'll start there. That's a lot of air conditioning load that you can end up with. Motors and transformers. Transformers are now DOE 2016 is the now minimum, or the new minimum standard for transformers. One problem here. Can you tell the difference between these two and the efficiency of them? Is it on the label? Nope. So unfortunately, this is probably one of the tricky ones to pick or to actually get compliance, because you have to actually go look in the book to find what is the efficiency of this thing. And motors, the new standard is now NEMA premium is the new minimum efficiency, which I think for those a lot of it has already been built to that over the years. You know, I think industry has kind of pushed the energy efficiency. Now there is a newer motor coming out that's even more efficient than that. As you can see, it looks a little different. A square motor instead of a round motor. These tend to be a couple of percent more efficient, but at least that I can tell that that's something's different there. Transformers, you can't tell. If someone's doing the performance path and using renewable energy credits to help cut down, their demand, again, we're trying to get to that 58% of the reference. Well, one way to do that, I can get a net zero home. You just put enough panels on it and I can get to net zero. Well, that's not really what we're after. So the code now put a limit on it of you only get up to 5% of your credit can come from on-site renewables. So you don't end up with a solar greenhouse. But this also allows you as the code officials to request the documentation. Okay, you've taken advantage of this solar. Show me that you actually are producing that much solar. So some of that, if something looks out of whack, that's why they just make it easy where you just say, just show me the numbers. Maintenance and commissioning, it now requires in the code operations and maintenance manuals to be provided to the building owner. It also requires that they provide a list of here are the normal O&M things that you need to do. And I have to tell you as part of that, it can say, change air handler belts twice a year. But I have to tell you which book and page to go to find belt size, belt tensioning, any steps involved. So I don't have, I have to tell you that, yes, you need to change the belts, but I have to tell you where in the documents to go look. Because almost any building that ends up with O&M documents, it's just a giant stack of binders. It's like, well, that's great. Where do I find it? So this has to be provided. This is one of the difficult areas is because it's within 90 days of the certificate of occupancy. Well, your jurisdiction typically stops at certificate of occupancy, normally. And so to say, well, this has to be provided within 90 days after the date at which I'm done. So I'm not sure how you can basically tell the building owner, you better be expecting this. If not, go after your contractor and get this from him. That's a little hard because you guys probably aren't dealing directly with the building owners. So that's kind of the big stuff for commercial. Residential, this is the #1 area that we have seen problems with compliance. Do either of you require building permits on replacement windows? That's where we have seen most of the problems are in this area with windows. Because, and this is kind of strange, the good windows, the windows that meet these requirements are on the shelf at the store. The ones that don't typically are a special order. But somehow people figured out to go special order the bad windows to save a few dollars. It's like, it's a little bizarre. This is a little backwards.
So is it difficult for you guys to require a permit for window replacement?
Sometimes it comes down to catching everybody too.
Uh-huh.
And that's one of the things that's hard, just like roofs, you require permits for roofs, but boy, is it hard to catch everybody doing one because they can be in and out of there in 2 or 3 days. You get to larger areas, you may not be back around that area for 2 months.
Yeah.
But
2 or
at
3
least
days,
if
that's a
you-
long roof crew.
Pardon me?
Yeah, 2 to 3 days, that's a long roof job.
Exactly, that's one of the tough things, it's kinda like windows, you don't really see the people, you know?
Yeah.
But wouldn't it be a bad idea to require if they don't comply?
No, it wouldn't.
Yeah, but
But one of the things is now, we do require if they're enlarging the window, because you're changing the header, it's structurally.
Sure.
just replacement, don't.
Yeah. Yeah. So that's where this is one that we find that this is a common weak point is windows. You can see here
It's easy to comply and difficult to not comply, and they find a difficult way to not comply.
You're really working to not follow this. But yeah, so there's been a nominal improvement. Best in class windows right now are a U factor of 0.11, so I guess our value and U factor are typically roughly reciprocals of each other. So this would be roughly an R3 for the windows. Best in class right now is running R9. So there's a lot of potential there. I think I hope we'll cover it. If I don't cover it, remind me, as far as a label, requiring a label typically near the service panel as far as the building components for new homes. Ducts in conditioned space. The code now provides some additional criteria as far as how do you determine if the ducts for modeling are in a conditioned space or not. So obviously if it's totally inside the air barrier, it's inside the conditioned space, which that's the easy one. Or buried in the ceiling insulation and meets those requirements. Now, duct leakage testing for normal ducts is 3 CFM per 100 square foot. So this is half the normal allowable limit. So tight ducts, full depth insulation, and the air handlers inside the air barrier. So that's the provisions they provided as far as conditioned space or not. Residential high efficacy lighting is now up to 90% of the lamps and fixtures installed, up from 75. And this is the big one, low voltage the exception is gone. Because that's common where we'd say, oh, we got all this track lighting with all those little MR16s. Well, it's low voltage, so it doesn't count. That exception's gone away. Multifamily, not sure how frequently you guys run into this, but for people using models, it allows batch samples to be used. So if you have 2 identical units that are side by side, and they're basically totally designed the same, they only have to submit 1 model and just say, this covers both of these units, before they had to model each unit. This kind of makes a little more sense that they're identical. I'll just tell you that's unit type A. Energy rating index. Have any of you dealt in the HERS ratings much at all? Had any done? This is one change that they made, which actually is going to reduce how stringent the HERS rating system is. We believe this is trying to help encourage people to use the HERS rating system. And so by reducing the stringency, hopefully they'll get more people to use it. To be totally honest, I wish every for sale sign had to have your, tell me your energy bill right under the, last year's energy bills. So it's like, oh, I don't want to pay that every month. This was, I believe, new in 2015. Existing buildings. So now the energy code covers existing as well as retrofits, or provided a separate section for it. Basically noting just conform to the new construction, but you don't have to change anything that's unaltered. You know, so if you're changing the lighting in the room, okay, the lighting has to comply, but you don't have to do anything about the wall insulation. Or if you're doing a new flat roof, okay, you got to bring the roof insulation up to the requirement, but you don't have to pull the HVAC equipment to do it. Now, you end up, because of some of this, you say, well, okay, in order to bring the roof insulation up on that flat roof to a code compliant level, I need to add 3 inches. Well, because of the curbs and the parapet walls, I only have room to put 1 inch of insulation in. Okay, give me the 1 inch then, because that's the best you can do with what you have without having to touch your unaltered sections. Now, I would imagine for HVAC, it would be nice to lift that stuff up to, if nothing else, just for the technicians to work on it a little easier. But that's something where you say, again, this is existing construction. There wasn't an energy code in the 50s or 40s. And so saying, okay, how do I make it the best I can with what I have? Now they do note that existing cavities, so if you take the drywall off and you've now exposed the cavity, you have to either bring it up to the current required insulation level, or at the very least, fill the cavity with insulation. Now I do note here, Chicago, and I do think this is a good practice for masonry buildings, to allow that air gap behind to make sure that wall can dry. Because, anything, if it can't dry, it will die.
Well, that's what it was designed so it doesn't wick through.
Exactly. Yeah. So that's one that
You're
when it says
you're giving it the wick through.
Exactly, and that's where it's like, okay, fill the cavity, and so they looked at it and said, okay, fill the cavity. You can provide your air gap, but then fill the rest of the cavity. So, okay, that's again trying to say, how do we do something that we don't kill a building? So, if you do have buildings that do have a lot of excess fenestration, old factories that are redone into some new use, or they want to replace the windows. Now the code calls out you have a maximum area of 30, possibly 40% of the wall area can be windows or fenestration. Now if you have an existing building that already has 60%, well, you can keep the 60% as long as you don't enlarge it. But the new windows have to meet the current standard as far as U value and solar heat gain. So, again, we are here to help you, your building owners, architects, engineers, if you run into questions as far as, okay, I have this situation, how do I make it work? Or, because we cover anyone in the state of Illinois, it may be, you're probably, you may not be the first people to encounter an issue, and so we can say, okay, here's kind of how other people have decided to handle that. And assuming noted approval, you guys have been given much more latitude as far as, again, existing conditions. What can you do with what you have? So trying to help with that.
So not only just, you can ask us questions, but if you have any horror story or fun story to share, let us know.
Or I ran into this problem, and here's how I looked at solving it. We love learning from other people and helping pass that, spread your knowledge.
Because we meet code officials and designers, architects, up north, south, west, east. So we could be, kind of hub for the energy code related information. So if you have any fun story that we can tell to other code, hey, you know what, we heard from Mount Sterling that they have this situation and this is how they went about. So also those are useful information for us. So I think our presentation is about here. So if
any other
you have any
questions?
questions,
Challenges, issues, problems you want to solve?
sometimes code officials send us like a drawings, and architects and engineers too. They're like a comp check, red check report, and say, hey, this is what I got, and I'm not sure. What do you think? And of course we don't know the answer all the time. Internally, we have a team of people who are looking at the same thing and scratching our head and trying to come up with the best answer. So, I think it's better to have more people to think about one issue. So if we cannot, provide you one perfect answer, we'll try. So let us know.
I did mention in the code now, I believe in the residential section, it now requires posting of a report of the major building components. So things like attic insulation levels, fenestration U values, and solar heat gain coefficients. And it must be displayed in a permanent location. Normally we'll see it at the next to the service panel or on the back of the service panel cover.
Was put on panels, and then they ended up people changing it up.
Yeah. And so the important reason why we see that the code calls out doing that is, that little U value sticker that was on the window when it was delivered, yeah, it's long since gone.
Yeah,
And so if I break a window, I need to make sure that I don't put in something that is a worse window than was there before, because I may throw off my heating and air calculations and end up short on that if I end up putting in a worse window. Which, are you guys doing manual J's, or what kind of heating and cooling calculations are?
Computer program called AccuLoad.
Okay.
From Adtech.
You're okay.
We use similar rights all.
Okay. So you guys are actually doing a full manual J. Okay. That's because that's I think that's another area that we run into, that people are like, I can't find someone that'll do a manual J. Because the code says manual J or another approved method. So that's one of those others that we look at and say, okay, how are people compliant?
Well, thank you all for coming. And as we mentioned before, please just contact us if you have energy code related questions, comments, stories, anything. Just let us know. And we will have a webinar this Wednesday for commercial lighting. So if you are interested in signing up and sign up for our newsletter, and that'll be it. Thank you so much for coming.
Thank you.